Some of the biggest discoveries in science happen when you're not even looking for them. This is one of those stories. It's about a theory that kind of stumbled out of a forgotten corner of physics and accidentally pointed to a truth about our universe that's more strange and beautiful than anyone ever imagined.
So, let me ask you a question. What if everything, every particle, every force, everything you can see and touch, is just a different note being played on some single cosmic instrument? It sounds like poetry, right? But this absolutely wild idea came from one of the most chaotic times in the history of physics. And before we can get to the music, we have to talk about the noise. In the 1960s, physicists built these huge, incredible new machines to smash atoms together. And what they found? Well, it was pure chaos. It felt like every single time they ran an experiment, some brand new, completely unexpected particle would come flying out.
They even gave it a nickname, the particle zoo. Seriously, you had pions, kaons, deltas, sigmas. A truly bewildering list of new species with no clear family tree. And all those elegant theories that described the rest of physics, they were completely useless here. It was just a mess.
But hidden in all of that noisy, messy data, a young physicist named Gabriele Veneziano found something. And it wasn't another particle, it was a pattern. He was sifting through some old notes, and he just stumbled upon a single, forgotten mathematical formula.
A formula that, in his own words, seemed too simple to be true. We're talking about a dusty old equation from the 18th century. But somehow it perfectly described the chaotic mess of the particle zoo. All that complex data from those giant accelerators could be summed up by this one elegant piece of math. It just worked.
And it also solved this huge puzzle they called duality. Think about it like describing a coin. You could describe the head side or you could describe the tail side. Well, physicists had two totally different ways of describing particle collisions, and everyone thought they were separate things. Veneziano's formula showed, no, they're just two sides of the same coin. It was this one unified description, and that was a massive breakthrough.
So this was the billion-dollar question. The formula was a stunning success, no doubt, but what did it mean? It was like finding a key that miraculously opens every single door, but you have no idea what the key itself is actually made of. What was the physical reality hiding behind the math? So physicists tried to reverse engineer it. They tried to figure out what kind of universe this formula was describing. And what they found was, well, it was deeply disturbing. For one, it predicted particles that travel faster than light, so-called tachyons, which would totally break the law of cause and effect. And even worse, it predicted ghosts, things that had a negative probability of existing, which is just mathematical nonsense. The theory was broken. So they were stuck. They had this beautiful formula that perfectly matched reality, but the formula itself seemed to describe an impossible universe, just full of ghosts and paradoxes. It really felt like a dead end.
For years, this formula just sat there, a beautiful but totally flawed mystery. And then, a handful of physicists asked a really radical question that was about to change everything. You see, the problem was that for all of modern physics, particles were always seen as these infinitely small points. But the new idea was shockingly simple. What if they're not points? What if every single fundamental particle is actually a tiny, vibrating, one-dimensional loop, a string? Okay, think of a guitar string. It can vibrate at different frequencies to create different musical notes, right? Well, what if a low-energy vibration is an electron, and a higher-energy vibration is a quark? All of a sudden, that infinite list of particles wasn't a problem anymore. It was a prediction. They were just the different notes from a single cosmic guitar string.
This one idea just transformed everything. The chaos of the particle zoo was replaced by the beautiful, perfect order of a symphony. All those different particles, the pion, the kaon, and hundreds of others, they weren't fundamentally different things at all. They were just different notes being played by the universe.
Now, this idea was absolutely breathtaking. Not only did it explain away the particle zoo, but it also fixed the math. The ghosts, the paradoxes inside Veneziano's formula, they all completely vanished. But there was a catch. They only disappeared if you followed two very strange, non-negotiable rules. The first rule was just a number. That's right, the math only worked. The ghosts only disappeared if the universe had 26 dimensions. Not 4, 3 of space and 1 of time, but 26. The equations were completely unforgiving. In any other number of dimensions, the theory just broke. It fell apart. Only in 26 dimensions did the math become perfectly consistent and beautiful.
And then came the second shock.
The theory predicted that one specific note, one particular vibration of the string, would have the exact properties of the graviton. That's the long-sought-after particle that carries the force of gravity. Nobody had even tried to put gravity into the theory. It just appeared out of nowhere.
And that was the ultimate accident. The whole thing started as an attempt to explain one specific force of nature, and on that front, it actually failed. But in failing, it had accidentally stumbled upon something so much grander. It wasn't a theory of one force, it was a theory that automatically included gravity. By complete accident, it had become the first real candidate for a theory of everything.
So let's just recap that wild journey. A mysterious formula shows up out of the chaos of particle physics. The only way to make any sense of it was to imagine particles not as points, but as tiny vibrating strings. This beautiful idea turns the particle zoo into a cosmic orchestra. But it comes with a price, a 26-dimensional universe, and it unexpectedly predicts the existence of gravity itself.
The entire journey, this whole story, it started with a really simple goal, just to find some kind of order in the chaos of the particle zoo. And what they found instead was an idea so profound, it suggests that maybe the universe isn't made of things at all, but of music. It's such a powerful reminder that sometimes the biggest discoveries are the ones we make by accident. It really makes you wonder, what else is hiding in plain sight, just waiting for us to discover it?